I know that cosine of theta is equal to -4/5. I want to find, oh, and also I'm given that sine of theta is, let's go negative. So I want to find the following things. I want to find sine of theta. I want to find sine of 2 theta. I want to find cosine of 2 theta. And I want to find tangent of 2 theta. Okay. To do any of this, we're going to, ow, son of a gun. Just hit my foot on the board there. I was reading about how the podiatrists are seeing a lot more foot injuries because people like aren't wearing shoes at home, myself included. I'm wearing socks and banging their feet against various things. So I guess it's true. Anyway, so what I really want to point out is when you're given like cosine equal to something or sine equal to something, most of the time the idea here is that this is an angle that we aren't really familiar with. I don't know what angle gives you -4/5 for cosine. It's okay. We don't have to know the angle. What we do have to know is what cosine looks like when you're thinking about a triangle. So if I draw the triangle for this, I know that cosine is the adjacent over the hypotenuse. So I'm going to say the adjacent side is 4 and the hypotenuse side is 5. And I didn't actually mean to pick such nice values. Darn it, I meant to do something slightly different. Let me change that just a tiny bit. Sorry. I want to pick something that was a little less good. Let's say cosine of theta was -3/4. Sorry. So the adjacent is 3, the hypotenuse is 4. What I want to emphasize here is that I don't care about the negative sign, right? I'll deal with the negatives later on. I'm just going to draw the triangle. So the third side of my triangle, so the other triangle I drew, the hypotenuse, sorry, the other side would have been 3, right? Because it would have been a 3, 4, 5 triangle. This is not a 3, 4, 5 triangle, right? It's only a 3, 4, 5 triangle if the hypotenuse is 5 and the legs are 3 and 4. So to find the other side of this triangle, we have to use the Pythagorean theorem. So I'm going to call this y. I'm going to say 3 squared plus y squared equals 4 squared. So y squared is going to equal 16 minus 9. And then y is going to be the square root of 7. And again, I'm not really caring if it's positive or negative. I'm just drawing a triangle where everything is positive. So then I want to find sine of theta. Okay, well, that's really, really easy for this problem. I know that sine of theta is the opposite over hypotenuse. So it's going to be square root of 7 over 4. But we have been told that sine of theta is negative. So it's negative. Great. To find the rest of these, we have to use the formulas. So to find sine of 2 theta, we have to remember that sine of 2 theta is equal to 2 sine theta cosine theta. And then we know what sine of theta is. It's -7 over 4. And we know what cosine theta is. It's -3 over 4. So this looks like it's going to be, let's see, so this is 2 over 1. So this is 2 times -7 times -3, so that's going to be positive 6 root 7 divided by 1 times 4 times 4 is 16. And you can reduce this if you wanted, right? This reduces to 3 root 7 over 8. So that's our sine of 2 theta value. Cosine 2 theta, similarly, cosine 2 theta is equal to cosine squared theta minus sine squared theta. Plugging in what we know, so cosine theta is -3/4, so that's going to be -3/4 quantity squared minus the sine squared, which is, sorry, sine of theta is, where'd you go? -7 over 4 quantity squared. Okay, weird. What is over here? or it's coming apart. So let's see. A negative number squared is positive, so that's going to be 9/16 minus 7/16. 9/16 minus 7/16 is 2/16, which reduces to 1/8. I could also, and I usually do at this point, ask what quadrant is the angle 2 theta in? 2 theta is in, well, first of all, what quadrant is the angle theta in? Well, since cosine is negative and sine is negative, theta is in the third quadrant, right? All students take calculus. It's got to be this one, where both cosine and sine are negative. 2 theta, well, if I look at sine of 2 theta and cosine of 2 theta, sine of 2 theta is positive, cosine of 2 theta is positive, and since they're both positive, the only quadrant where sine and cosine are both positive is in the first quadrant. So 2 theta is in quadrant 1. Okay, and then lastly, what's tangent to 2 theta? So I will tell you, there is a formula for tangent to 2 theta. You should never memorize it. It's terrible. Instead, what we should do is be like, well, if I want to find tangent of something, I know it's sine of the same something divided by cosine of the same something. So I think I have it from here. Tangent of 2 theta is just equal to sine of 2 theta divided by cosine of 2 theta. But we know each of those. Sine of 2 theta is 3√7/8. And cosine of 2 theta is 1/8. Multiplying, flipping and multiplying, you get running out of room. This would be 3√7/8 times 8/1. Which would then equal just 3√7. So there's your tangent value, 3√7. Which again, well, not really. I'll take more water. Okay. Let's look at some more questions. Let's look at one like this. Find an exact value for. So when somebody says find an exact value, they mean do not use a decimal approximation. Let's do the following. Let's do, sure. Let's do cosine of 25 pi over 6. Oh, that's the one that's in there. Fine, that's all right. And then let's do sine of, sure, 11 pi over 12. Okay. 25 pi over 6 is one of our kind of typical angles, right? We recognize it as having a reference angle of pi over 6. And then we can see that 25 pi over 6. So if I do 25 divided by 6, right, that's going to be 4 with a remainder of 1. So I know that this is the same as cosine of 4 pi plus pi over 6. But 4 pi is 2 full revolutions, which gets you back to the same spot. So this is going to equal cosine of just pi over 6, which is going to be the square root of 3/2. Right? And generally, especially in your final, but just in general, if someone asks you to find cosine of an angle like this, they don't want the decimal approximation. I don't want 0.86 whatever. We want the actual value, which is the square root of 3/2. Just as a kind of to go along with this question, what if instead we asked for, I don't know, cosine of 29 pi? That's not what I want. Let's do 31 pi over 6. So again, if we kind of think about doing the division, 31 divided by 6 is 5 with the remainder. Sorry, coming in. So, right, this equals cosine of 5 pi plus pi over 6. Because 5 pi is 30 pi over 6 plus 1 pi over 6 is 31 pi over 6. Now here's the thing. 5 pi is not some number of 4 revolutions, right? 5 pi is 2.5 revolutions. So the way you should think about this, or at least the way I would think about this, is say, okay, well, I'm just going to draw the picture. There's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. And then I'm going to go a little bit more. So there's my 5 pi plus pi over 6, or 31 pi over 6. The reference angle is still pi over 6, but the quadrant is not quadrant 1, it's quadrant 3, where cosine is negative. So here the answer would be negative. Just be careful, right? When you're kind of when your biggest multiple of pi is an odd multiple of pi, you have to be like, oh yeah, I'm over here, and then where do I end up? Okay, let's look at sine of 11 pi over 12. So if you see something pi over 12, that's a clue that you have to use the angle sum formula. So we're going to write this as the sum of two angles, both of which are going to be fractions over 12 that reduce. I'm going to say this is sine of, and now there's going to be multiple options. I usually try and pick the smallest thing. So I know it's not 1 pi over 12 plus 10 pi over 12 because 1 pi over 12 never reduces, but 2 pi over 12 plus 9 pi over 12. Those both add up to 11 pi over 12, and they both reduce. This reduces to 1 pi over 6. This reduces to 3 pi over 4. So that's going to be sine of pi over 6 plus 3 pi over 4. And then we have to use the formula. Pens don't suck. Oh, they're all pretty good still. So this is going to be sine of pi over 6 times cosine of 3 pi over 4 plus cosine of pi over 6 times sine of 3 pi over 4. Right, let's see what we got here. Sine of pi over 6. Well, we know that cosine of pi over 6 is root 3 over 2. Sine of pi over 6 is 1/2. Cosine of 3 pi over 4. So cosine of pi over 4 is root 2 over 2. 3 pi over 4 is in quadrant 2, where cosine is negative. That's going to be negative root 2 over 2. Plus cosine of pi over 6 is the square root of 3 over 2. Sine of 3 pi over 4 is positive root 2 over 2. Because we're in quadrant 2. Okay, and then we're going to simplify. So this simplifies as negative root 2 over 4 plus square root of 3 times square root of 2 is square root of 6. And we usually write this as, you can write it as negative root 2 plus root 6 all over 4. But the more standard way of writing it is the square root of 6 minus the square root of 2 all over 4. Questions about that? Okay, I'm going to give you guys one to try yourselves because I need to go reach my water bottle. So I have to try this one. So use the formula that cosine of A plus B is equal to cosine A times cosine B minus sine A times sine of B to find, what do I want to give you? Sure, let's do cosine of, let's do that, 17 pi over 12. So find two angles that add up to 17 pi over 12 and that both reduce to something over 4 or something over 3 or something over 6. So work on that for a minute. I'm going to go into my water bottle. Okay. Now be fully hydrated. So there's literally a bunch of ways you could do this. I feel like the easiest way to do it would be to pick 2 pi over 12 and 15 pi over 12. Usually 2 and whatever is left over works, although not always. But right, you could have made a different choice. You could have said, I'm going to pick 8 pi over 12 and 9 pi over 12. The reason I like this kind of choice is because that means one of your angles is going to be in the first quadrant, and it's usually easier to deal with. But both of these would be correct. But you could write, and obviously there's other choices as well. You could do 3 and 14, right? Those both reduce. You could do, yeah. So anyway, but typically you want to pick something small. So I'm going to do this as cosine of pi over 6 plus 15 pi over 12 reduces to 5 pi over 4. I should point out that when you do this, you definitely want to pick things that reduce to fractions whose denominators are 3, 4, or 6. I'm just trying to think here for a second. Yeah. That's kind of, we don't really have any other choice. Yeah. Okay. So this is going to be cosine of pi over 6 times cosine of 5 pi over 4 minus sine of pi over 6 times sine of 5 pi over 4. Let's see what we get. This is going to be, cosine of pi over 6 is the square root of 3 over 2. Cosine of 5 pi over 4, again, it's a pi over 4, so we know it's root 2 over 2, but 5 pi over 4 is in quadrant 3, so it's going to give us a negative value. And then sine of pi over 6 is 1/2. Sine of 5 pi over 4 is, again, it's a pi over 4, so it's a root 2 over 2. And we know it's going to be negative because, again, we're in quadrant 3, where sine and cosine are both negative. Okay, so now, simplify. And again, when you simplify these angle sum problems, they always simplify as something root 6 over 4 plus or minus root 2 over 4, right? It's always a root 6 and a root 2 all over 4. This is going to be a negative root 6 over 4 minus a minus gives you a plus root 2 over 4. And if one of them is positive and one of them is negative, I always write the positive one first. So I would really like to write this as the square root of 2 minus the square root of 6 divided by 4. That's it. See, what else have we got here that we haven't kind of talked about? Sure, let's solve some trig equations. Seems like on the homework, most people did perfectly fine solving the trig equations. It's straightforward for everybody, which is good. Let's take it, just do a couple examples. So let's say I have the equation, and these won't be like too terrible. 1 minus cosine x equals cosine x. Oftentimes I'll make you do maybe a tiny bit of algebra first. If I'm going to solve this, I'm going to have 1 equal to 2 times cosine of x, and then cosine of x is going to equal 1/2. There are 2 places where cosine is positive in quadrant 1 and quadrant 4. So looking for angles in quadrant 1 and quadrant 4. And I know I want cosine to equal 1/2. My reference angle, which is also going to be one of my answers in quadrant 1. Is going to be cosine x equals 1/2. I know that x is pi over 3 or pi over 6. Oh, it's pi over 3. So pi over 3 is one of our answers. So in quadrant 1, our answer is x equal to pi over 3. You don't have to list what quadrants they're in. I'm just listing it to show you guys. In quadrant 4, our answer is, well, let's see, in quadrant 4, it's 2 pi minus pi over 3. which is 6 pi over 3 minus pi over 3, which is 5 pi over 3. Or you can also do the thing where you're like, well, if I know it's in quadrant 4, 1 pi over 3 is in quadrant 1, 2 pi over 3 is in quadrant 2, 3 pi over 3 is the line, that's pi, 4 pi over 3 is in quadrant 3, and 5 pi over 3 is in quadrant 4. That's another way you can do it. And another one. I'll remind you, if there's a specific question you guys have or want to see, I'm happy to do them. I'm just trying to pick the trig things I think are kind of the stuff I've seen people have the hardest time with. Let's see, how do I want to phrase this one? Sorry, I'm a little tired. Let's say I want to solve. Am I likely to do that? Probably not. Sure, let's do this one. Sorry. Cosecant squared x minus cosecant x. We might have done one like this before, but it's still good practice. So the key thing to notice here is that we have a quadratic equation. You can change it to different variables if you want. Like you could say, typically u is used when you do a change of variables. You can say that u is equal to cosecant of x, and this is u squared minus u minus 2. Which this does factor as u minus 2 times u plus 1. Which you could also, so you could either solve, so you could get u minus 2 equals 0, u equals 2, u plus 1 equals 0, u equals 1. Or you could just go back and say, well, I can see that it's going to factor as cosecant of x minus 2 times cosecant of x plus 1. So then setting each variable to 0, oh yeah, we get cosecant of x equal to 2, which is the same as saying u is equal to 2, and cosecant of x is equal to negative 1. So we have to solve those. I don't usually remember what makes cosecant what. I remember that cosecant is the reciprocal of sine. So that if I take the reciprocal of both sides, the reciprocal of cosecant is sine, and the reciprocal of 2 is 1/2. Same deal here. The reciprocal of cosecant is sine. The reciprocal of negative 1 is 1 over negative 1, which is still negative 1. Okay, so I'm trying to find the angles where sine is equal to 1/2. That's going to be in quadrants 1 and 2. I think the reference angle we're looking for is, what is that reference angle? It's pi over 6. So in quadrant 1, my angle is pi over 6. In quadrant 2, my angle is 5 pi over 6. And we're also looking for where sine is equal to negative 1, which is at the bottom of the unit circle, where my angle is, right? You can even draw it. There's my unit circle. There's the bottom at the point 0, negative 1, and the angle is pi over 2 by 3 pi over 2. So those are the 3 answers to this equation. Okay, kind of interesting. Might be almost done. Okay. Let's look at this next one. So here's, I want to simplify this to a single trig equation, trig expression. Yeah, and maybe might change this one just slightly. Could you please turn it back to this side? Sure, why not? Just for you. Just for you. You good, Fernanda? Sure. So basically, here's the deal. For a value like 1/2, I know that there's angles that I know the reference angles, right? I know for 1/2, the reference angle for sine is pi/6, and then I find whatever the angles are. But for values like negative, so basically, if you've got sine or cosine equal to either 1 or 0 or -1, we know that those values only occur at the quadrantal angles, at the angles that are on one of the axes. So what I did was I said, okay, well, I'm essentially using the fact that we know that the unit circle, right, that the point on the unit circle, if your angle is theta, that this point on the unit circle, which we sometimes call xy, that this is also equal to cosine theta, comma sine theta. So what I really did was I said, well, I know that my unit circle has a radius of 1. And I said this point here is 1, 0, and the angle is 0. This point here is 0, 1, and the angle is pi/2. This point here is -1, 0, and the angle is pi. And this point down here is 0, -1, and the angle is 3 pi/2. So if I'm trying to find the place where sine is equal to -1, well, sine of my angle is the y-coordinate. So I'm looking for the place on the circle where the y-coordinate is -1. And there's only one place. It's right here. Right? Anywhere else, the y-coordinate is higher than -1, so it's not -1. So this place here is the only place where the y-coordinate is -1, and the angle there is 3 pi/2. So sine of 3 pi/2 is equal to -1, and that's the only angle in one revolution where that's true. You're very welcome, of course. Okay, so we were going to do this. Let's see here. So I want to simplify. I wonder where this is going. I have an idea. Let's see. So I want to simplify the square root of tangent of x plus cotangent of x divided by what have we got there? Cosecant of x minus sine of x. I think this will turn out to be all right, but it might not. Okay, so if I'm going to simplify this, I'm usually going to turn things into things with sines and cosines. Yeah. I think I want to do the. Yeah, I think I'm going to actually flip it over. Sorry, there's something I want to show you guys, and it's better to show you if I flip it over. Sorry, let's make it this: cosecant of x minus sine of x over tangent of x plus cotangent of x. Okay. So we're going to simplify this. So this is going to be equal to the square root of, so cosecant is 1/sine. I keep carrying things outside. Just birds creepily looking at me. Sorry, I got distracted there. Apologies. So 1/sine minus sine over tangent, which is sine over cosine, plus cotangent, which is cosine over sine. Now here's the deal. We know we're going to have to flip and multiply at some point. But the thing is, you can't flip and multiply this denominator until it's a single fraction. You can't say that this is this minus this times the reciprocal of that, like that. It doesn't work that way. We have to make this one fraction before we can do any flipping and multiplying. So I'm going to get common denominators in the numerator and the denominator. It's going to be, so I've got 1/sine. Minus, I'm going to multiply this by, right, this is sine x over 1. I'm going to multiply it by sine over sine to get sine squared x over sine x. In the denominator, I'm going to multiply this by, so I need a common denominator, so I'll multiply this by sine over sine, and this by cosine over cosine. Let's see what we get. So sine times sine is sine. So I should say, right, sine squared x over sine x cosine x plus cosine squared x over sine x cosine x. So simplifying a bit, putting all of our fractions together as one fraction, both the top and the bottom, I get 1 minus sine squared all over sine. We know that 1 minus sine squared is cosine squared. And then in the bottom, we get sine squared plus cosine squared, which we know is 1 over sine x times cosine of x. So this reduces to the following. We get cosine squared x over sine of x over 1 over sine x times cosine x. I think I might have made, not a mistake, but just, this might not end up being exactly what I wanted, which is fine. Yeah. Interesting. I definitely got an extra term somewhere that I didn't mean to get. I wonder. So I'm just curious about something here. That's fine. This is going to be equal to the square root of cosine squared x over sine x times the reciprocal of this, which is sine x times cosine x over 1. I can cancel a sine here and a sine here. So I end up with the square root of cosine cubed x. Or if you want, you can write this as cosine of x to the 3/2 power. It's a little weird. Let me take a look at one thing just to see. Sorry, I'm just looking at the. Oh, look at the solution for a second. Just curious. Oh, okay. That's the problem. The problem is that, so I was like, so here's my issue. I was thinking, usually when these problems say simplify to a single term, you just get like a trig function knocked to a power. And the mistake I made was that I didn't quite read the problem perfectly correctly. If you look at the problem, well, I changed it a little bit, but the original problem, if you look at it, there is a cube root there that is actually pretty hard to see. It's not that hard to see, but if you're looking at it from way back here, yeah, it's very easy to miss. So there should have actually been a cube root there. And then the cube root of cosine cubed is just cosine. Yeah. Which makes more sense. Okay. Good. I'm not losing. I do not intend to ask you about graphing tangents. So you can not worry about that if you don't want to worry about that. What else? What else? What time is it? Okay, we got like 12 minutes. Okay. Let's see. We could. Trying to think of those other. Trying to think about what other trig things might come up. I feel like that's kind of most of the things. Let's do one of these. Sure. Yeah. Okay, here's another type of question that I often like to ask. Let's say sine of A is equal to, let's not make it that. Let's say it's equal to 1/3, and cosine of B is equal to, numbers don't suck, 2/3. Let's go negative 2/3. I also know that cosine of A is positive. I know that sine of B is positive. And the question is the following. This is I feel like the way I'm going to phrase this is yeah, no graph or tangent. Yeah. Not on the final anyway, right? They may come up in life, but not on the final. So the question I'm going to ask is, what quadrant is the angle A plus B in? I don't love that question. Yeah, I'm going to change one thing. I'm going to make sine negative 1/3 here. Okay. So I have to think for 1 second here. Just 1 second. Oh no, that's fine. Okay. Yeah. So we don't know, right? We do know what quadrant angle A is in. And angle A is in quadrant 4 because sine is negative and cosine is positive. And we know that angle B is in quadrant 2 because cosine is negative and sine is positive. But we don't know what angle their sum is in. Sorry, we don't know what quadrant their sum is in. It could be, there's probably 2 good choices that both are possible. We have to figure out which one it is. So how do you figure out what quadrant an angle is in? Well, the typical way of finding it is determining what sine of A plus B is and what cosine of A plus B is. And determining, right, if these are both positive, we're in quadrant 1. If this is positive and negative, we're in quadrant 2. If this is both negative, we're in quadrant 3. If this is negative positive, we're in quadrant 4. So that's what we're going to do. We're going to determine what they are. To be able to do this, though, we have to use the formula. So the formula for sine of A plus B is sine A cosine B plus cosine A sine B. And the formula for cosine of A plus B is cosine A cosine B minus sine A sine B. We have parts of it, but we don't have all of it. So we need cosine of A and sine of B. So we need some triangles. So sine of A is 1/3. We have to find the other side. So this side, let's call it x. We know that x squared plus 1 squared equals 3 squared. So x squared equals 9 minus 1 is 8. So x is equal to the square root of 8. And then for angle B, cosine of B is negative 2/3. Again, I don't care with a negative sign. I just care if the cosine is 2/3. And then to find this other side, let's call it y. 2 squared plus y squared equals 3 squared. So y squared equals 9 minus 4. So y equals the square root of 5. Now we can find all the things. So let's see, sine of A plus B is going to be, so cosine of A is going to be equal to, cosine of A is going to be positive root 8 over 3. And sine of B is going to be positive root 5 over 3. But we know they're positive because we were told they were positive. Okay, so sine of A is negative 1/3. Cosine of B is negative 2/3. And then cosine of A is root 8 over 3. And sine of B is root 5 over 3. So let's see what we get. We get negative, so positive 2/9 plus square root of 8 times square root of 5 is square root of 40 over 9. And this is definitely positive. Great. So we know that since sine is positive, we're either in quadrant 1 or quadrant 2. Let's find cosine. The cosine of a plus b is going to be cosine a, which is the square root of 8 over 3, and cosine b, which is negative 2/3, minus sine of a, which is negative 1/3, times sine of b, which is square root of 5 over 3. Okay, so this is going to be a little more work. We're going to have, let's see, negative 2 root 8 over 9 plus the square root of 5 over 9. So the question now is, okay, which one is bigger? Is the negative thing bigger or is the positive thing bigger? Oh, the negative thing is definitely bigger, right? Square root of 8 is bigger than square root of 5, let alone 2 times the square root of 8. So this is more negative than it is positive. This is going to be less than 0. So since sine is positive and cosine is negative, we can say that a plus b is in quadrant 2. Because sine is positive and cosine is negative.